Hello everyone, I am Mohd Asif Ansari, a student at CEPT University, Faculty of Technology, pursuing a Masters in Construction Engineering and Management program. This presentation is a part of my Studio One coursework for the Monsoon 2024 term under the course Construction Project Formulation and Appraisal. Today I will be presenting the Bridge-cum-Barrage project, a critical infrastructure initiative aimed at addressing water management and urban connectivity challenges. This project has been developed with the guidance of esteemed faculty members. This project highlights the integration of engineering and management principles to solve real-world challenges, making it an excellent case study for understanding the feasibility, design, and execution of large-scale infrastructure projects. Let us move to the project brief for the Bridge-cum-Barrage project, a transformative greenfield infrastructure initiative aimed at addressing critical water management and urban development challenges. With an estimated cost of 928 crores, this municipal corporation funded project is designed to create a freshwater storage reservoir with a capacity of 19.17 million cubic meter at a full reservoir level of 5 meters. Its primary objectives include preventing salinity increase into the riverbed, enhancing groundwater recharge, and providing a new road corridor to alleviate traffic congestion. This project also has a very much contribution to the increasing population of the city and providing them the drinking water. This project is strategically positioned to ensure water security and urban connectivity. Through innovative design and sustainable planning, the Bridge-cum-Barrage project aims to support long-term growth and resilience for the region, making it a vital addition to the area's infrastructure. Now, let us move to the financial analysis of the Bridge-cum-Barrage project. This financial analysis of the Bridge-cum-Barrage project focuses on its cash flow components and economical viability. The cash outflow includes a significant capital expenditure of 908.12 crores covering initiation phase, design and construction phase, and project management costs, with construction being the largest component at 879.16 crores. Operational and maintenance cost over 25 years amounts to 63.78 crores, with annual increase of 7% for operations, electricity and water, and 5% increase for maintenance. The cash inflow is generated through two primary sources: raw water supply revenue estimated at 938.47 crores and advertisement revenue from the hoardings and poster totaling to 316.66 crores. Assumptions include an 8% annual increase in costs and revenues, a 5% discount rate for net present value calculations, and inflation rate of 8%. Operational expenses are detailed on the right, with staff costs contributing 344.5 crores, electricity as 85 crores, and maintenance of 207.9 crores over the project life cycle. These figures establish a comprehensive view of the project long-term financial dynamics, highlighting substantial investments but also significant revenue potential. The revenue from raw water supply is projected for 30% of the city population over the years, starting with 24.58 crores in 2029 and growing to 59.18 crores by 2052. However, the raw water rate remains constant at 0.002 per liter. Moving to the base cash flow statement, we see the major cost components include a capital expenditure of 908 crores and operational costs totaling 638 crores over the project lifespan. Advertisement expenditure is 296 crores with corresponding revenue from the advertisement pegged at 316 crores, contributing marginally to inflows. Despite these revenues, the net present value is significantly negative at 321.96 crores with an internal rate of return of just 2%. The payback year is projected as late as 2049, indicating a long recovery period. In conclusion, while the project ensures critical water supply, its financial metrics suggest unprofitability, reinforcing its necessity as a public welfare initiative rather than a profit-driven venture. Now we will move on to the sensitivity analysis of this project. In this, we have considered scenario 1 of 50% reduction in advertisement revenue and scenario 2 of 5-year delay in construction of the project. Scenario 1 assumes a 50% reduction in advertisement revenue compared to projections, while revenue from the raw water supply remains 938.46 crores. Advertisement revenue drops to 158.33 crores. This results in a negative net present value of rupees 384.80 crores, an internal rate of return of just 1%, and a payback year extended to 2051. In the scenario 2, it examines a 5-year delay in construction where project costs are adjusted for inflation, capital expenditure rises to 1434.68 crores and operational expenditures increase proportionally. Despite revenue from the water supply and advertisements, the net present value worsens to minus 519.81 crores with an IIR of 0% and the payback year shifts further to 2057. Both scenarios emphasize the financial risk associated with unforeseen delays or reduced revenue streams, highlighting the importance of efficient execution and realistic revenue expectation to mitigate losses. Let's move on to the design brief of the Bridge-cum-Barrage project. The design brief for the Bridge-cum-Barrage projects it consists of the barrage design and the bridge design. Starting with the barrage design, it adheres to IS codes such as IS 11150 for construction practices, IS 12720 for spillway design, and IS 6966 for hydraulic guidelines in alluvial reaches. The design components include barrages, piers, and divide walls, with considerations such as the highest flood level at 10.092 meters and monsoon discharge at 68,000 cusecs. Moving to the bridge design, the project complies with IS 456 for concrete structures, IS 875 for design loads, and IS 6 for road specifications. Components include girders, deck slabs, and the road. The key parameters are a soffit height of 12.75 meters, a total river width of 523.3 meters, and a 4-lane 70R class carriageway with pedestrian walkways on each side. These specifications reflect a robust and standardized approach to address structural, hydraulic, and operational challenges, ensuring the project meets safety and performance expectations. Let's move further to the bid process management. Bid process management ensures the efficient execution of the Bridge-cum-Barrage project by maintaining transparency, fairness, and competition in bid process management. The process begins with defining the project scope through feasibility studies, project management, design, and proof checking. These tasks are divided into 4 work packages involving feasibility consultancy, project management consultancy, proof checking consultancy, and engineering, procurement, and construction contractors. For consultant procurement, the quality and cost-based selection method is adopted with an 80:20 ratio, prioritizing quality over cost due to the project's complexity. The contract type is a percentage-based success fee contract, and the bidding system used is a single stage to envelope process with open tendering to ensure competitive transparency. By carefully aligning procurement strategies with project needs, this project minimizes risks and ensures timely and cost-effective delivery. Let us move further with the evaluation of the consultants, in which first point is eligibility. A bidder must have completed similar projects amounting to at least 50% of the estimated cost in the last 5 years. Next is the technical capacity. This includes completing one similar project worth 80% of the total project cost, or two projects worth 50% of the total estimated project cost or cost of work given, or three projects worth 40% of the estimated cost of work provided to the consultancy services. Financial capacity requires a minimum net worth of 12% and an average annual turnover of 40% of the estimated cost of work. Personal capacity ensures qualified experienced professional related to the scope of work. Additionally, a solvency certificate covering 20% of the estimated cost of work is mandatory. For final scoring, a combined score of technical and financial evaluations will determine the successful consultant. Now, let us discuss the procurement strategy for the EPC contractor for the Bridge-cum-Barrage project. The procurement is based on the least cost selection method, as this is a high-risk critical project requiring experienced contractors with expertise in similar works. The contract type is engineering, procurement, and construction, utilizing a single-stage two-envelope system through open tender inquiry. The evaluation process has two levels. Level 1 is the techno-commercial bid evaluation, followed by level 2, the financial bid evaluation. The selection criteria ensures contractor meets specific capacities. The eligibility of the contractor includes completion of similar works, at least 50% of the estimated cost of project in the last 5 years. The technical capacity involves at least completion of at least one project of 80% of the total estimated cost of projects, or two projects of 50% of the total estimated cost of projects, or three similar projects of 40% of the total estimated cost of project. The financial capacity includes a net worth of 12% of the total estimated cost of projects, and the bidder must have an annual turnover of 40% of the estimated cost of project. Personal capacity includes qualified and experienced professionals relevant to the project scope. Further on, addition is of available bid capacity of the contractor, which is calculated by the formula A into 2 into N minus B, where A is the maximum value of engineering work executed in any 1 year over the last 5 years and B represents ongoing commitments. Next additional conditions are included. The bidder must have successfully completed at least one barrage or dam project with roller compacted concrete exceeding 2.4 lakh cubic meter, hydromechanical works of 77,000 metric ton, and excavation of 12.5 lakh cubic meters. A solvency certificate is required covering 20% of the estimated project cost. The risk transfer analysis reveals that risks like construction, design and procurement are significantly transferred to the EPC contractor through effective bid process management. This ensures greater accountability and reduces the burden on the project owner. Risks such as force majeure and political risks remain with the owner, while operational, financial and quality risks are largely shifted to the contractor. In conclusion, this project evaluates critical aspects of the proposed Bridge-cum-Barrage, focusing on financial analysis, design considerations, and bid process management. Financial analysis concludes that from a financial perspective, the project shows a negative net present value, indicating that future cash flows cannot cover the initial investment. The initial rate of return is lower than the discount rate, making it financially unattractive. However, given its vital role in addressing the growing population's drinking water needs, its importance extends beyond monetary returns. The design brief concludes. The design brief ensures structural integrity by considering river flow, seismic activity, and environmental impacts. It prioritizes efficient water flow, flood control, and sustainability. Detailed schedules and cost estimates outline a clear framework while emphasizing quality standards, safety protocols, and adherence to local regulations. The bid process management concludes that it ensures a transparent and competitive selection of consultants and contractors. Clear documents, effective communication, and robust evaluation are the key to selecting qualified service providers who can deliver the project on time and within the budget. This comprehensive approach addresses financial, technical, and procedural challenges, ensuring the project meets its critical objectives for public benefit.